Good day, everyone. Welcome to this class. In the last class, we treated how to read analog inputs from a potentiometer. In this class, we're going to be treating on how to control the brightness of an LED using a potentiometer. Now, there are some certain things I want you to know. First, your Arduino board operates with 1 or 0. So you can say it uses a square wave to operate. If you have some knowledge of electronics, you might know what I'm talking about. So, but let's just leave it as a digital device that operates between 1 or 0, on and off. So, in most cases, when we want to read an analog device like a potentiometer, we will have to use the analog inputs. Now, let's recall that for devices we are working with, we work with both digital and analog devices like motors and the rest. So, how are we able to work with it efficiently? Now, if you're working with a DC motor, you might want to increase the speed or decrease the speed. But because of the nature of the Arduino Uno or the Arduino boards that we're using, you can't really do it that straightforward. So that is where pulse width modulation comes in. It's just a means of controlling the brightness or speed or power coming into a device. Now let me explain what I mean. Your Arduino board works very fast. Now, if we bring an LED and turn it, let's say put it on and put it on off, it appears as if it ons and off very fast, but that is not the case. There's actually a lag between the on state and the off state, but it happens so fast that you can't see it. So the PWM helps us, which has a timer, helps us to control the timing speed so that we can be able to see the fading brightness. And with that, we can be able to transfer it to other devices like the motor and all the other analog components. So, but for this class, we'll be using an LED. Let's get right into it. So the first thing we're going to do is bring out your LED. Bring out your resistor. Change the values. Now, look at your Arduino board. You see that I'm taking it from 9. And if you notice something about 9, is that it has a wave attached to it. It has a wave attached to it. Now, that waves you're seeing there indicates PWM, which means pulse width modulation. So pulse width modulation is going to help us simulate that fading that we don't see by reducing the speed at which the current or the voltage flows into the device. I'm going to take this to ground. Yes. So with this, our connection is complete. Let's go into the code. So we're basically going to be starting from where we stopped. Now, we're going to introduce, since we have added another device, we're going to mention that we're going to create a container to represent or variable to represent the device, which is LED, since the name is short, we use LED. And the container should contain the pin number that the LED is connected to. and we're going to introduce another variable called PWM value. Now, remember I said your Arduino is a digital device, so anything it operates with, it tries to convert it to a digital device. Now, even your potentiometer, when we were reading from our serial monitor, we were seeing that it was in values. Normally, it's not supposed to be like that. It's supposed to be in a waveform. But since your Arduino Uno is actually a digital device, it tries to convert it to a digital signal. So that's what this analog pin does. It tries to convert the analog signal coming into this LED, into this coming from the potentiometer to what? Digital signal. So this PWM value now, the value is between 0 to 255. So it actually represents the duty cycle of an LED. Now, what do I mean by duty cycle? It's actually the number of times your LED was actually active. So when you have it at 255, it means it was fully on. When you have it at 0, it means it was fully off. Maybe you have it at, let's say, 128 or some or thereabout, 127. It means it was on or on for most of the times. That is 50% of the time. So I hope you got that. That's what we're going to use PWM value. Now, from the input signal coming in from this potentiometer, we are going to transfer or map the voltage into the what? LED. Now, what happens is that this potentiometer is going to help us regulate the voltage we are bringing out into the LED. So before we get to that, let's go to our void setup and actually set up our LED. Remember, your LED is an output device. Okay, this is good. Now, we're going to use something called map, the map function. Map function. Now, what the map does is that it maps the input signal coming in from your potentiometer onto the duty cycle of an LED so that it will be able to control the voltage that is passing through that LED. Let's map port read, which is the signal coming in from your potentiometer. So by doing so, we've successfully mapped out our potentiometer input to our LED. So at 1023, the LED should read 255, meaning it should be fully on. So we're going to assign this to the PWM value. Now, on to the next line. Remember, when we're working with a digital device, we use digital write, but now we're not going to use digital write. Since we have converted the LED to a digital device with the help of the PWM, we're now going to use analog read. Sorry, analog write. Has to be correct. Now, so we're going to pass in this function. So what happens is that when we turn the knob, this code we just read that when we turn the knob and it's reading a value of, let's say, 1023 or 0, meaning that what we are telling the LED to do is that at that value, the pulse width modulation value is 0 at 0. If we read a port value of 0, the PWM value also should be what? 0. And what happens is that once it's 0, the LED is off. But once it gets to 255, once we read the value of 1023 by rotating our knob, it should be 255. And what happens is that the LED will turn on. So when you put the knob in between, maybe any value you get is going to correspond it into this range so that it will regulate the power of voltage coming into this LED device. So let's just see what we're seeing. Okay, now this is I think this should be the highest, if I'm not, okay, close to the highest. Okay. Okay. So what we're gonna do now? Let's stop this simulation first. Carry this down. We're going to introduce a delay, very important. We've also done that. So the values won't be reading very fast. So now your LED is working at full mode. Okay, now let's see what happens if we take it up half. You see the brightness of your LED has reduced. Let's see if we take it further down. See, it gradually reduced until it came to off fully. So that is how to control the brightness of your LED using your potentiometer. So all you have to do is take note of your pulse width modulation pins, make up your connection, map out your function so that the input signal coming from the potentiometer can control the voltage coming into the LED, and then you have your results. Thank you very much. See you in the next class.